So last month, the Succinct team released OP Succinct, which helps turn any OP stack rollup into a full Type 1 ZK rollup in just 1 hour using SP1, which is general purpose ZK. I spent 8 hours understanding its architecture, how OP stack chains can turn themselves to use ZK proofs, and why it is a game changer for rollups and Ethereum ecosystem. So watch this video till the end, and we will learn how the OP Succinct Tech works in depth and save your multiple hours. And trust me, you wanna know this information ahead of time. Oh, and follow me too if you like blockchain and Web3 technical content. So quickly, in the initial part, we will check out what exactly our Succinct team is building and then how they are changing the OP stack, right? So first things first, what is ZK? What is zero knowledge? In simple terms, what ZK lets you do is write a proof that some function, when run with certain set of inputs, public or private inputs, results in some output. And mostly the type of statement that you are trying to prove are like, oh, I have a bunch of transactions, and then I run the EVM, the Ethereum virtual machine, and process all those transactions, and I get the balances and the state of the world. So this is what, ZK has been used for, and, you want to prove these kind of functions with ZK, right? And ZK lets you do that, right? So now to actually make your function ZK provable and to generate a ZK proof of it, you need to write it as a circuit. So basically you need to write it in a specific form, which is like very complex and known as circuits. And to maintain these circuits, you need a specialized team, and it might need to be redone when new proof system comes out, right? So in short, like ZKP adoption has been held back because it is bad, and building like ZKP systems has been extremely complicated. But Succinct Proposal 1, SP1, is changing that narrative. It is designed as a general purpose ZKVM, which basically solves this problem and creates a future where all the blockchain infrastructure, like any rollups, bridges, or coprocessors, and they utilize ZK proofs via maintainable and software written in Rust, not in a circuit, basically in simple Rust, right? So SP1 basically like uses this uses precompiles, right? So think of precompiles are like some kind of short work for a complex task. So in ZKVMs like SP1, precompiles are like specialized circuits designed to like handle heavy operations such as like hashing or tech curve computation and like signature verification, and much faster than standard code, right? In traditional ZKVMs, executing like a cryptographic function like SHA-256 or Kachak involves like a series of, risk-free instructions that can be slow and costly, and especially when repeated across like many transactions. So SP1, enables teams to like, in general, use ZK proofs in production with minimal overhead and fast timelines. So this is what, SP1 is. So in SP1, you just take the function you want to prove and write it in Rust, then it compiles the program to like RISC-V ISA and generate a RISC-V EL file, right? So SP1 will prove the correct execution of arbitrary RISC-V programs by generating a stark proof of execution. And one thing to remember, that behind the scenes, this old circuit stuff is like, still happening. But it's for developer, it's a very good experience for them, right? And because you just need to write a Rust code, right? So circuit stuff is still happening, but for developers, it's a very good experience now because you just have to write Rust code now. Okay, so I think we have talked about SP1. Now let's go to our main topic, which is like OP Succinct, right? So a quick recap for everyone who don't know how like the OP stack works, right? So without a doubt, like OP stack is the easiest rollup stack out there because you do not need gigabytes of RAMs like you would have needed for any ZK protocol, and it's built in a super modular way. Plus, it's open source as well. Kudos to them. So in general, an OP stack rollup works by like batching transactions, off chain, which a sequencer currently, which is centralized, right? So centralized sequencer, and then it orders and bundles into batches and creating like blobs, right? And that represent like transaction data. The sequencer compresses these blobs and posting them to the Ethereum L1, right? Now, going a bit too deep, so any OP stack rollup has this smart contract that has like the state root of the rollup, against which like all the withdrawals, like the bridging is done. The contract is called L2 output oracle contract, which contains like array of L2 state outputs where like each output is a commitment, where each output is a commitment to the state of the L2 chain. Like other contracts, like there is Optimism portal contract, like they use these outputs to verify information about the state of the L2, right? And yeah, so now the correctness of this particular smart contract is ensured by the fraud proof claim. So that's like the optimistic fraud proof interactive challenge of Optimism, like the 7-day challenge period in Optimism, like where the window is which anyone in the 7-day challenge period, and there's a window during which anyone can dispute state update, right? Then there are these 4 main components of OP stack, which we are going to discuss in a bit, right? But yes, the existing OP stack system relies on like a 7-day fraud proof window, which causes a transaction delays if like dispute arises and everything. And this is how like OP stack rollup works in short, in general, right? This was a simple explanation. And one very important reminder, like the end game of Ethereum scaling is that every rollup is a ZK rollup. And in this world, users will no longer have to like wait for 7 days to withdraw fronts from any rollup, right? So now let's also discuss like the 4 main components, right? You will get to know later why I'm discussing this. But yeah, every OP stack rollup is composed of 4 main components. One is like the OP get that takes transaction from users and uses them to like generate block and execute blocks. Next is the OP node, which reads batches data from L1 and like uses it to drive OP get in non-sequencer mode to perform like the state transaction stuff. And then we have OP batcher. So OP batcher basically batches the transaction from users and submits them to the L1, right? L1, the Ethereum L1, right? And the last one, and the important one for this video, is OP proposer. So what does OP proposer do? OP proposer posts an output route to L1 at like regular intervals, which captures the L2 state. So the withdrawals can be processed, right? So this basically, there is OP proposer updates this particular contract that we just like the L2 output oracle contract. Okay. Yeah, so these were the main components. Now just make sure to remember OP proposer and this particular contract. Okay, so now let's discuss what were the changes made to OP stack by the Succinct team, right? So what Succinct team did was it changed the OP stack state transaction function into its ZKVM, which means one can generate validity proof of the rollup state transaction function and use ZK proofs to bridge to Ethereum or other settlement layer, right? But what does this actually mean? I mean, this is what everyone has been saying, but what does this actually mean, right? So the first thing the Succinct team did was replaced the smart contract that contains the L2 state outputs, like the L2 output oracle contract that we just discussed, with a ZK version of this smart contract, which is now the OP Succinct L2 output oracle, right? And the difference is actually pretty small. It's like 50 lines of code that has been added to the new contract, right? So whenever it posts a state route, so alongside it also posts a proof. Then you verify the proof, that particular proof using ZK, and then you know that like the state route is correct. So they replace like that smart contract with like a ZK version that verifies the proofs itself, right? So alongside posting a particular, so if you go to the back diagram, so in this particular OP Succinct setup, the contract only posts the state route. But when you come to the OP Succinct stack, Succinct Tech, this particular contract along with posting the state route, it also posts a proof itself, right? So the first thing was replacing this particular contract, right? And then the next thing that they change is that they took the off-chain agent that's updating that smart contract, right? Which is OP proposer. So which is responsible for like rolling up transaction states onto the contract itself. We just also discussed that like this is OP proposer. And they kept the other component, which is OP patcher, OP node, and OP get, unreplaced. They didn't touch it. So the only change happened was in the OP proposer, right? And they modified like OP proposer a little bit only, so that actually it can like generate the proof using SP1 API, then update the smart contract itself, right? So now let's see in the diagram how the OP Succinct service actually works. So basically it consists of two containers, which is one is the OP Succinct proposer and the other one is OP Succinct server. So how do they actually like work together, right? So the proposer monitors the L1 state to determine like when to request proof, right? And then it sends proof requests to the OP Succinct server, and then the server, it receives proof requests from the OP Succinct proposer, right? And then it generates the witness for the proof and then submits the proof to the Succinct prover network. So this prover network is like a distributed network of provers that can generate a proof of any size quickly and reliably, right? This is like a Succinct prover network. And then, so the server basically, you know, it handles the communication with the Succinct prover network to fetch the proof status and, you know, complete the proof data. And then one thing here to notice is that the proposal itself is not generating proof, right? So it is given out to like to Succinct prover network to like generate the proof itself, right? So once proof have been generated for sufficiently large range, the proposer aggregates range proofs into an aggregation proof and then submits the aggregation proof to the OP Succinct L2 output Oracle contract, which includes like the L2 state outputs we just discussed. And then now along the side, this also you know, posts a proof which will be you know, verified, using, you know, ZK, right? So tada! OP Succinct has transformed any OP Succinct rollup into fully type 1 ZK Ethereum rollup with 1 hour finality secured by ZK proof. So yeah, so these were the only changes that the Succinct team did to OP Stack, right? So last thing, how can someone update OPs using OP Succinct rollup? And there are like very simple steps to that. So the first thing that needs to be done is deploy the Oracle contract, which we just discussed. So you just deploy the OP Succinct L2 out and then start like the OP Succinct proposer service and basically, you know, update your chain configuration, simple as that. And you know, this is like pretty awesome because basically in the end, you can just take any OP Stack rollup and you can like deploy one smart contract on chain and you can just spin up one very lightweight service, right? Because the service itself is not generating proof. We discussed it previously that the service itself, the OP Succinct proposer, is not generating proof. It is dispatching it out to like the Succinct prover system, right, to generate the proof, and it keeps the smart contract updated, right? And yeah, so that's service that the team needs to run who wants to change to OP Succinct Tech. The existing OP stack also, you know, it relies on like 7-day proof window, and which causes like transaction delays if any dispute arises and stuff. And OP Succinct, like, it shortens this transaction finality time by using like ZK proofs and eliminating the need for extended fraud proof window, right? So I think OP Succinct can significantly like reduce transaction costs. Historically, if you wanted a full ZK rollup, for example, like a ZK rollup that exists today, like ZK Sync or Polygon ZK VM or let's scroll, normally one would have to like they will need a sophisticated advanced team of like, you know, 30 cryptographers, PhDs coding like a specialized circuit of EVM with like for the ZK rollup. So you literally have like this long, complicated code base that's like hundreds of thousands of lines of code just to code the actual state transaction function logic of that rollup. And that has been done, right? But still, you know, I mean, that is possible, but it's difficult. It takes time. It's hard to maintain. And when Ethereum upgrades, they have like, you have to change all the circuits and stuff, right? So also a lot of these rollup aren't even type 1. So for example, they have like differences with the Ethereum virtual machine, the EVM, and with like OP Succinct, you can build a fully type 1 ZK rollup, right? So yeah, if Ethereum's future scaling solution is to convert all the rollups into a ZK rollups, in this world, users will no longer have to wait 7 days to withdraw funds from a rollup, right? And if OP Succinct proves successful, it may even pose like a challenges to traditional ZKVM based rollups. Obviously, the tech has to prove itself, and there are a lot of things. But in my personal opinion, I feel like this is a great tech, and we might see a few major rollups. Like, it's my personal opinion, like using that are built on OP stack. They will be using SP1 like Succinct, OP Succinct Tech very soon, and the OP stack rollup and convert like OP stack rollup into a fully verified ZK rollups, right? So yeah, I think that's it for the video. Thanks a lot for watching it. If you like technical content, blockchain technical content, do follow me. If you're watching it on YouTube, subscribe. If you're watching it on Telegram, there is also a link to a Telegram channel where I usually, post some develop stuff, hackathons, grants, and all that stuff. Just developers and builders alpha. So you might want to join that too. But yeah, feel free to reach out to me too if you need any help or anything. Thank you so much. I hope you enjoyed this video. And I'm trying to create more and more technical stuff. So like it'll help people and understand more blockchain stuff and Web3 technical stuff. So do support. Thank you so much.